This is 17.4 sample exercise 17.9. Hang on, I want to make sure I give you the right. 741 is the page if you want to follow along with that. 741, and we're going to be doing another one next from 7, where is it at here? 742, so the next page over. So the first one here is refreshingly short, so let's get right to it. This is talking about the expression for the solubility product constant. For first, to be able to do this one, you should probably write out what's happening, the dissociation of calcium fluoride. And calcium fluoride breaks up, of course, into calcium with a +2, and then we have fluoride. But don't forget that because of the 2 here, we have 2 fluorides like that. Now, excuse me. What I didn't write or forgot to write was the solid here. Now that makes a difference because we know, going all the way back from the first time we did equilibrium, that this is a heterogeneous equation, which means that we are not going to write down the concentration of CaF2 solid, because solids and pure liquids do not have a concentration other than 1. It's just the amount of the solid that's there, not a concentration. So we end up with then as the KSP of this equal to the concentration of Ca with a +2 and the concentration of F minus 1, but because of the 2, that comes down as an exponent 2. Okay, so this is what it is, and it actually is, if you look in the back for Appendix D, you will see that it's 3.9 times 10 to the negative 11th. Now this is a very, very small amount for a KSP, which means that these concentrations are going to be very small also. So let's move on, make this as quick as possible. This should be a refreshingly short sample problem. So this one says calculate KSP from solubility. Solid silver chromate is added to pure water. 25 degrees, the solid remains in the bottom, blah, 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 blah. So silver 2 chromate, analysis of the equilibrated, that's not even a word, solution shows that on silver ion concentration, the silver ion concentration, okay, which means this, is equal to 1.3 times 10 to the negative 4th, and that's molarity. Okay, assuming that Ag2 CrO4 dissolves completely in the water and that there are no other important equilibria, that is a real word, involving the Ag plus or CrO4 2- ions, then solution, calculate the KSP for this compound. So the first thing that we're going to need to do is figure out what the concentration is for the chromate ion. So chromate, this is, to be able to do this, though, we're going to have to know that obviously if I got silver and chromate together, then I'm going to, oops, not what I needed. I'm going to need the 2 here for the silver, which means that what I'm getting, and I'm mixing up my equations, which means that I'm going to have 2 here, +1s, and then a CrO4, just one of these is a -2, which means that my KSP will be equal to silver +1 squared times chromate -2, like that. Okay? We should be able to find both of these. So let's take a look. As far as the chromate is concerned, we're going to take the 1.3 times 10 to the negative 4th. That's our concentration over 1, and we're going to multiply. There are, for every 1 mole of chromate, there are 2 moles of silver, like that, which means that chromate ion has a concentration of just 6.5 times 10, where are we at here, to the negative 5th, like that. And then all we do for the KSP then, to find the KSP, is to put in the 1.3 times 10 to the negative 4th, square that, and then multiply that by the 6.5 times 10 to the negative 5th, and that stays to the first power. Let me pull down here just to get a little bit more room. Like this. So KSP then should equal, where are we at here? 1.1 times 10 to the negative 12th. And there's our KSP for silver chromate. Okay, that's it. Those are pretty easy problems. We're going to practice a whole bunch of these, obviously. So go ahead and submit that along with your notes, please, to the same assignment for Thursday, December 10th.